Problem 2. Multiplying and dividing functions. Let f of x equal x squared minus 9 and g of x equal x plus 3. What are f times g and f divided by g and their domains? Well, first, f times g of x is equivalent to f of x times g of x. F of x is x squared minus 9, g of x, x plus 3. So we multiply these two binomials and arrive at, in simplified or standard form, x cubed plus 3x squared minus 9x minus 27. The domain of both f and g, the original functions, is the set of real numbers. So the domain of f times g is also the set of real numbers. F divided by g of x, well, we know that equals f of x divided by g of x. In this case, that's x squared minus 9 over x plus 3. Now, x squared minus 9, if we recognize that as a difference of cubes, we can quickly factor it as x minus 3 times x plus 3, and that's still over our g of x expression, x plus 3. The x plus 3's cancel, and we find the simplified form of the expression on the right to be x minus 3. That, of course, is provided that x does not equal negative 3, because an x value of negative 3 in the denominator leads to a 0 denominator and an undefined expression. The domain of f over g, or f divided by g, is the set of all real numbers except x does not equal negative 3, because g of negative 3 equals 0. The definition of f over g requires that you consider the 0 denominator in the original expression for f of x over g of x, despite the fact that the simplified form has the domain all real numbers. Your turn. Let f of x equal 3x squared minus 11x minus 4, and g of x equal 3x plus 1. What are f times g and f divided by g and their domains?